Okay, for our learning objective in this lesson, uh, we will be defining what is momentum and identify the forces that influence momentum. And lastly, we can solve the value of P, M, and V of the unknown variables. So, the concept provided to be momentum is defined as mass and velocity product. So that is P is equals to M times V. So it is also known as a body's difficulty in during a sudden stop. So mass and speed are the two variables that influence momentum. So momentum, P stands for the momentum, and it's directly proportional to the mass, which is M, and velocity, which is V, based on the formula provided. So the materials that we were going to use will be the chalk, whiteboard, marker, and visual materials, and I will be providing the activity sheets after the discussion. And on topic, what do you do when you are at the peak of your study or you are doing something, then your mother called you? Anyone? Okay. What do you think would be the reasons or reason why you will not immediately obey your mother? Okay. So, what probably you felt is called momentum. So, in our today's lesson, we will know and understand what would be the meaning of momentum scientifically or in a scientific way. A while ago, we said that what you felt is momentum. Now, based from your experience, what does momentum means? Okay, anyone? Okay, that's right. Basically, momentum is affected by two factors, which are the mass of the body and its velocity. Okay. And then, let's find out again from your experience, which is harder to stop, the bicycle that moves slow or the one that is fast? Okay. And then, what could be the factor that affects the momentum of the bicycle? Okay, that's right. Now, let us verify if mass really affects momentum. I need a student that is heavy and a student that is lighter, and two volunteers that will stop them. Okay. So, okay. Which from your heavy and lighter classmate is hard to stop? Of course. So, what do you think is the reason why he or she is hard to stop? Okay. What could be the mathematical formula of momentum? Okay, very good. Now, for us to clearly understand the mathematical view of momentum, let's have this one. A is equals to B divided by C. This equation shows the relationships of the three variables involved. So what are the three variables involved? Okay, correct. Now, let us relate A and B and B and C. So if we are going to look at its location as part of the fraction, we can immediately understand its relation from one another. So let's start with A and B. If we're going to look at it, what part of the fraction is A and B located? Okay, that's right, numerator. Now, please keep this in mind that if two variables are in the same location as part of a fraction, then they are directly proportional. What that does mean? It's good. One variable increases and the other one also increases. Very good. So, with the relationship or the relationship of A and B, you can answer. That's right. A and B are directly proportional. As A increases, B will also increases, and vice versa. Very good. Now, let us look at the other variables. We want to compare which is A and C. So, where is a variable located in the fraction from A and C? Okay, let's start with A. How about C? That's right. A is the numerator and the C is the denominator. Therefore, what conclusion can you make? Very good. As C increases, A will decrease. Okay. So that's right. Now, going back to our lesson, mathematically speaking, momentum defines as P is equals to M times V, where P is the momentum and the M is the mass and the V is the velocity. So, what conclusion can you make based from the equation? Okay, that's right. Mass and velocity are directly proportional with momentum. That's right. So, let us have an example. Situation 1. A. Its velocity is 5 meters per second. And then the B. Okay, its velocity is 5 meters per second. So, okay. So, let's say the A would be the bicycle and the B would be the track. So, which do you think will have greater momentum, or which will in return harder to stop from its moving state? Okay, very good. Okay, so why do you say so? For example, here in situation B, which is the track, even though they have the same velocity. Okay, that's right. Since a track is more huge, in fact, than a bicycle, therefore, okay, the mass is directly proportional to momentum. So, we immediately know that the track is harder to stop than a bicycle, since the momentum is not influenced by velocity. Okay, very good. Now, let's have another example. Okay, what if situation A is its velocity is 2 meters per second, and the situation B is let's say its velocity is 6 meters per second, and they both have 15 kilograms of mass. So which possesses greater momentum? Okay, why do you say so? The object B would be it possesses the greater momentum. So, what if both the mass and velocity are different? No quantity or variable is constant in both cases. Okay, if that's the case, we can use the formula to calculate the value of momentum. So by the way, what is the unit of the momentum? Okay, kilogram. Okay, meter per second. Correct. Since mass unit is kilogram and velocity is in meter per second. So we can just combine the two to have kilogram meter per second. Very good. Okay. So that's the end of our discussion. So generally, momentum is a mathematically defined as the product of mass and velocity of a body, which is P is equals to M times V. Conceptually speaking, momentum is the difficulty faced by a moving body or object to undergo sudden stop or jerk. So the factors that affecting momentum would be the mass and the velocity. So the relationship of momentum to the mass and velocity would be the mass and velocity are directly proportional to the momentum, meaning whenever one increases, the other one will also increase, and vice versa. So now I will be distributing a activity sheets for you to answer.